Question 1. The figure below is made up of a square and a rectangle. The area of the square is 5/6 the area of the rectangle. The area of the unshaded part of the square is 7 out of 9 the area of the unshaded part of the rectangle. And the shaded area is 30 cm square. What is the length of the square? Some of you might be wondering, do I need to use algebra? Do I need to use simultaneous equation? Do I need to use units and parts? Well, you can, but actually there's a much simpler way. In fact, this is a ratio question. In particular, constant difference. Before I start explaining why is it a ratio constant difference kind of questions, let me just highlight. The area of the square is 5 and the area of the rectangle will be 6. Then the area of the unshaded part of the square will be 7 and the area of the unshaded part of the rectangle will be 9. Given that this is 5 units and this is 6 units, what is the difference between their area? Obviously, it's 1. Okay. After that, they mention, imagine they remove this shaded part from each of the shape and then they compare the area. It is 7:9. You think about it. If the difference between them originally is 1 unit and you remove the same area, in this case the shaded area, from both shapes, then the difference between them should stay the same. Hence, isn't this a constant difference question? In the first case, the difference is 1, and in the second case, the difference is 2. What we are going to do is to change 5 out of 6 into its equivalent fraction of 10:12. Why? In this case, we would get a difference of 2 units. Matching the second case, which also have a difference of 2 units. Hence, given that at the beginning, the square has an area of 10 units, after that, it becomes 7. Why? Due to the removal of the shaded part. So the 3 units, the drop in 3 units from 10 to 7 must be equal to 30 cm square. We can double check using the rectangle. If there's a drop of 3 units, the rectangle should also have a drop in 3 units from 12 to 9. And it fits the story. Now we can write out 3 units must be equal to the 30 cm square. From here, 1 unit is 30 cm square divided by 3 to give you 10. And given that the area of the square is 10 units in total, therefore area of the square will be 10 times 10. Finally, in order to figure out the length, there are only 2 similar numbers when you multiply them together to give you 100, and we all know that it is. Okay, we're going to write back 10 again. The numbers are very nice, but it's okay. 10 times 10. Last step, length of the square is 10. Question 2. Figure A is a square formed using 2 identical tiles. So these are the 2 identical tiles. Not really drawn to scale, but it's fine. Figure B is formed by rearranging the tiles. So from here, technically you shift this gray tile down to form figure B. The area of figure A is 225 cm square. A rectangular footpath is constructed using figure B, meaning they're going to take multiple figure B and they're going to join them side by side in this manner, all right, to form the footpath. The area of the entire footpath is 2475 cm square. What is the parameter of the footpath? Which means they want us to find the length plus this breadth plus the length plus the breadth. Essentially, we just need to figure out how many figure B's are there. Before that, we need to figure out the dimensions of the figure A or figure B. Only then we can multiply. Let's zoom into figure A and B to analyze further. For those who are quick to analyze, you will see that this is actually equal to this, which is also equal to this. These three lines over here are of equal length. Why? Let me cut it out and shift it for you. Observe. So when I shift it down, isn't this matching with this? So let me move it back. I'm going to shift it down and observe about this part also. Alright, this is actually the same length as this. Up, down. Okay, that is why this is equal to this is equal to this. Hence, the length of figure A, we can split it into 3 equal units. Over here, we can do it with 2 parts, meaning here and here. They are the same. Let me move it one more time. You will see that. Alright, they are the same. Okay, so see that? We are now going to figure out the dimensions of figure A. Then from there, we can figure out the dimensions of figure B. Let me adjust it. Okay. We know that this is a square and the area is 225. Hence, what is the length? We can write our first working. Area of figure A is equal to 225 cm square, which is 15 times 15, isn't it? So this is 15 centimeter. 15 centimeter. And earlier on, we mentioned that we can split it into 3 equal parts, which means this is 5, 5, 5. On figure B, this will be 10. What about the length? The length is actually the entire 15, which is here, 15. And what about here? Since these two are the same, we can say that this is 7.5, 7.5. This is 7.5, this is 15. Hence, what is the total? 7.5 plus 15, we will get 22.5 centimeter. The dimensions of figure B is 22.5 by 10 cm. Next, we just need to figure out how many figure B's are there in total along the footpath. Hence, number of figure B along the footpath. Which is equal to 2475 divided by 225 to give us 11. There are a total of 11 figure B's. So right now we can figure out the parameter. The parameter of the footpath. Which is equal to, what is the length of the footpath? 11 of this on one side and 11 of this on the other side, plus the 10 cm breadth and the 10 cm breadth. So how many 22.5 again? 11 over here and another 11 22.5. So that is 22 of the 22.5 cm plus the 10 and the 10. 20 cm to give us the answer of 515 cm. Question 3. Linda used some sugar to bake 17 pies. A similar amount of sugar was also used to bake 7 cakes. Each cake used 50 grams more sugar than each pie. What was the total mass of the sugar used by Linda? Give your answer in kilograms. Let's analyze the model between one cake and one pie. So one cake and one pie. It is quite easy to compare the mass of sugar used, isn't it? So they mention each cake over here uses 50 grams more sugar than each pie. Alright? What about for 2 cakes and 2 pies? How will you expect the model to develop? You will expect 2 units each. So I'm going to extend it. The 2 units and the difference between them will it still be 50 grams? No, right? 2 cakes. So 100 grams more in total. Maybe let me shorten it. Something like this. 100. So do you see the pattern? What would the model look like for 3 cakes, 3 pies, all the way until 7 cakes and 7 pies? Let's change the model into 7 cakes and 7 pies. I'm going to condense the model to save some space. For 7 cakes, we would expect 7 units. 1, 2, 3, 4, 5, 6, 7. Same thing, 7 pies. However, what is the difference between the 7 cakes and the 7 pies? Per cake is 50 grams more. So 7 cakes you would expect to see probably something like this. Okay, maybe let me use up more space. Over here, 350 grams, isn't it? Again, per cake is 50 grams more than per pie. So 7 cakes you would expect to use 350 more grams. The question also mentioned Linda used this exact amount of sugar for 17 pies, which means from here all the way to here must be the amount of sugar used for the remaining 10 pies. Make sense? Hence, we can start off with the first step. Mass of sugar used for 1 pie. If we use 350 grams for 10 pies, then for 1 pie we will just take 350 grams divided by 10 to give you 35 grams. From this point on, it's actually quite straightforward. I think the simplest way to get to the answer is just to figure out the mass of sugar used for 17 pies, which is here, and then we multiply it by 2, since in both cases they use the same amount of sugar, isn't it? There is no need to separately go and find out the mass of sugar used for the cakes, or go and find them separately and add them up together. Alright, there's no need. So we can just go straight to mass of sugar sugar used for 17 pies. That would be 35 gram times 17 to give us 595 gram. After that, we just need to multiply it by 2. Total mass of the sugar used by Linda, 595 gram times 2 to give us 1190 gram, and we need to change it to kilograms, which is 1.19 kg. Question 4. The figure below is made up of two squares, the smallest square and the larger square. The difference in parameter between the two squares is 16 centimeters. The difference in area between the two squares is 120 cm square. Find the length of the figure. Let's first talk about the parameter. Where do the difference of 16 centimeter, where do they come from? The parameter of the small square is actually here plus here, isn't it? After that, you're gonna add here and here. This will give you the parameter of the small square. What about a large square? Where are the common length they share? For the large square, obviously it's here they share. Next, here, after that, here, and the last part here. The unhighlighted part is the difference between the parameter of the small square and the parameter of the large square, which means this portion plus this portion plus this portion plus this portion will give you 16 cm. What do the 4 equal red highlighted lines give you? When I move it this way, they form a square, isn't it? Hence, if this is the difference, which is 16 cm, it means that this must be 4 by 4 by 4 by 4. Let me write it down. 4 and 4. The area must be 16 cm square. 16 cm square over here. Now we can look at the difference in area between the two squares. They are 120, which means this entire area plus the 16 plus this similar rectangular area is 120. Hence, can we figure out the area of this rectangle? Area of, rectangle. I will just need to take 120 cm square minus away the 16. After that, I divide it by 2 to give us 52 cm square. This is 52, this is 52. From here, are we able to figure out the length of the rectangle, which is equal to the length of the small square? We can, right? Given that we know the breadth over here is 4. So, the length of the small square, which is the length of the rectangle. (52 cm square) divided by 4 cm to give you 13 cm. So this is 13 cm from here to here. Find the length of the figure, which is just one side, one length. From here we can see that it's 13 plus 4. The answer, length of the figure equal to 13 centimeter plus, over here, 4 centimeters to give you 17 centimeters. And that is the final answer.